I'm Tim. I'm from Google. I am one of the original Kubernetes developers. I came from the internal systems at Google. I worked on Borg before I worked on Kubernetes. So I realized this is a 25-minute slot, so while I prepped for 45 minutes, I did some mad slide editing this morning. So I'm going to try to rush through some of the background so I can get to the good stuff. Kubernetes, I think every talk so far has at least mentioned it, which is very, very gratifying. Thank you. Kubernetes is a container management system. You've heard the word orchestration, you've heard orchestrators. It is a system that is derived from the ideas that we built inside Google over the course of the last 12 years or so on how you should manage workloads, how you take containerized applications and push them out into a cluster of computers and take your hands off and let the system manage it for you. It is completely open source like everything else we're talking about here. The focus that I really want to emphasize is we talk about applications. We don't want to talk about infrastructure. We really want you to focus on your apps. So I stood up here, or actually at the other building, a year ago, almost to the day. I'm here now a little bit grayer and a little bit fatter to give you an update on all the things that have happened in Kubernetes. A year ago, we were almost at our 1.0, but not quite. So now here we are a year later. We've had 3 major releases in this year. Over this time, we've committed tens of thousands of changes to our GitHub repo. We have, just in this last cycle alone, over 5,000 commits. We are in the top 0.01% of GitHub projects. We have 800 plus contributors, which the Docker guys are like, yeah, whatever. We have hundreds and hundreds of projects that are claiming to be built on top of Kubernetes. We have dozens of companies participating. We have people who are using it. These are just the ones we're allowed to talk about. And this is really, it's all because of community. So I just want to say thank you. Everybody in here who has used Kubernetes, contributed to Kubernetes, read a document about Kubernetes and complained that it wasn't good enough, you guys are the things that are making this possible. So just a big thank you to everybody. So now, real quick show of hands. Who does not know the basics of Kubernetes? It's okay. All right, so I have an accelerated intro. Watch this. You start with these things called containers. You guys all know what containers are, right? We take a bunch of containers, we lump them together into this thing called a pod. Brandon made a passing reference to pod. It's just a group of containers that run together and share some stuff. Now, one of those things it tends to share is some space on disk. So we have volumes, which are like Docker volumes, but they have a lifetime that's bounded to their pods. We also add these things called labels. You can barely see that. We add these things called labels, which is very similar to Docker labels, to everything that's running in our system, so you can then find them later. We then have a concept called a replication controller. Replication controller's job is to replicate. All it does is it takes a pod cookie cutter and it stamps out that many cookies. Right? If you tell it, I want 5 cookies, it's going to look at the system periodically and say, do I have 5 cookies? I only have 4 cookies. Let me stamp out another cookie for you. Well, I have 6 cookies. Let me just pick one at random and kill it. So it also has labels. So then a replication controller, here we go, stamps out a bunch of pods. Those pods all have labels. Now, in this big soup of containers, I can use labels to select the ones that are interesting to me. Now, I got to do something with those containers. So I take those containers and I lump them together into something we call a service with a capital S because we couldn't find a better name. And a service is just a group of containers that get essentially a virtual load balancer stuck in front of them. Of course, services have labels too. You put it all together, you get your classic 3-tier application where you've got a bunch of your front-end applications managed by a replication controller. They talk to your mid-tier. Your mid-tier is grouped by a service, so if one of them dies, it gets replaced dynamically. Those talk to your back-end, which maybe has a persistent volume. Oh, I didn't talk about persistent volumes. I'll get there. It has volumes attached to it. You can store your database there. Boom, your application. Now, you know everything you need to know about Kubernetes, because that's basically what I presented last year. I went over my old slides, and that was it. That's what I did for 45 minutes. So now that you all have done 45 minutes in 45 seconds, let's talk about what's new in Kubernetes. I'm going to focus specifically on features that we launched in our 1.2 release, which is a couple weeks ago. And then at the end, I'm going to put out a couple of teasers for things that are not yet available, but are coming in our 1.3 release, which is due out this summer. So the first big thing, I'll start with the heavy hitters, is multi-zone clusters. You can now bring up a Kubernetes cluster with nodes in multiple availability zones, and we will automatically figure out how to balance your applications across it. This means that if you're running on something like Google Cloud or Amazon, which have strong guarantees about outages being one zone at a time, your applications don't go down. right? You run 5 replicas or 6 replicas, you're going to run across these nodes. I see people over there going, yeah, of course. It seems like such an elementary thing. We didn't have it at the beginning, we do now. What it really means for you as a user, 0 API changes. You run your replication controllers, your pods, everything as you would before, only now they get automatically spread. Excuse me. When you bring up a new node in your cluster, we figure out through the cloud provider what zone you're in, we label the node, and pods are auto-spread across those individual labels. We have this fully automated now for Google Container Engine and open source GCE. We have it automated for Amazon. And for now, if you're running something other than those platforms, we have to do it a little bit manually. But if you label your nodes in whatever environment you're on, including your on-prem, then it should just work. This is generally available in Kubernetes 1.2. We have full confidence that it works. This is the code name for this, which you might hear around, is called Kubernetes Lite. Kubernetes is an overarching project that we're working on for the 1.3 timeframe and longer that lets you do multi-zone, multi-region, single pane of glass control over multiple clusters. This is the first foray into that. So let's talk about the next thing. I talked about replication controllers in the fast forward. Replication controllers are fantastic. They have one job, they replicate. The problem is when you want to do something like a rolling update, the classic rolling update is you bring up a second replication controller and you drain all the work from one into the other one, and now you've changed it. These things have names, right? People as humans, we like names, we like to manage things, and if the name is no longer this durable thing, it's sort of annoying to people. So we got a lot of feedback that this was difficult for people to use, so we came up with a new concept called a deployment. And a deployment is essentially updates as a service. You create a deployment object, the deployment object creates the replication for you. You can then update the deployment object, and it will bring up another replication for you. Without you knowing about it, all you need to talk about is the deployment. This is now a fundamental primitive of a lot of the things we're doing. It gives you your stable object name, the updates. You can have configurable update policies, so you can recreate your deployment to do a rolling update, or you can do a rolling update. There's a bunch of parameters that you can tweak to change the behavior of the rolling update. But most importantly, the update happens server-side. Previous to this, rolling updates happen client-side in your command line. Now they happen server-side, so you can actually launch them and forget about it. It also comes with a bunch of built-in logic like undo, where it'll keep some history and say, you know what, this was bad, let's roll back to the previous version. It gathers up all the stats about what it's doing, managing your deployment, and you can actually have multiple updates in flight, and it will manage that for you. So I asked on Twitter last night, how many demos can I do, thinking I had 45 minutes. I'm going to see if I can do 3. So I apologize up front. I can't type and talk at the same time. So I have my self-typing demos here. I promise you, though, that they are real demos. They are running against my real Google Cloud cluster of Kubernetes right now. So just to prove it, I will run kubectl get nodes. And you can see these are all the nodes that are up in my cluster. So the first thing I'm going to do is run setup. What setup does, it's going to go out, it's going to look at something called namespaces in our cluster, which is a slice of individual identities. I'm going to create a new namespace called demos so that I can make a mess, and when I'm done with it, I can throw it away. So I've now created demos. You can prove it by seeing that demos exist, and it's now 2 seconds old. So deployments, demo. So the first thing I'm going to do, because I want to show you what we're doing, is I'm going to create a service. This service selects for any pod that claims to be in the demo deployment. Any pod that matches that selector is now going to be serviced by this virtual IP that's going to be allocated for me. So you can see now that has been created. So here is, we're off of the screen. Here is our deployment object. And I've left in a bunch of things that are really optional, but I wanted to show the features of them. So you can see things like here's our selector. It's going to match demo deployment. I'm going to create 5 replicas. It's going to do a rolling update for when I do an update with a max surge of 1 and max unavailable 0. So that means I'm going to create a new one before I destroy an old one. I can actually allow that to go faster by changing those numbers around. And then you can see what this container is going to do is, this pod actually has got 2 containers running in it. The first container simply runs while true echo hostname v1 into the index.html file and goes to sleep. That's all it does. Or sorry, it just echoes v1 and then it goes to sleep, right? The second container mounts the same volume, which is that same file that I wrote into, and it's going to serve it as HTML. Really simple. So the deployment is created. So what you're going to see here, in the middle section, I am going to SSH into my cluster, and I'm going to just start hitting my service. So you see that I'm pulling back all these random host names that are the 5 backends for my service. And you can see on the bottom left that I'm currently asking for 5 v1s, and I'm getting 5 v1s. Now in the top pane, I'm actually going to do an update. And I just passed it through sed, changed v1 to v2. So now you can see that in real time, my cluster is changing itself over to use v2. Now I decide, oh no, I botched it, v2 is a mistake. Let me stop that and undo it. And just like that, I start draining all my traffic back to it. Through this whole thing, the middle panel, no service outage. You saw your blue-green deployment. Some of your users might have momentarily seen version 2, but that's okay, it worked. It just didn't pass whatever test. And so now I've run it. That's it, that's deployments. Oh, stop. All right, so another question that we got a lot over the course of this year was, I have a cluster, I want to run this container on every machine in my cluster one time. I don't want to run it 2 on one machine and none on another. I need to run it exactly once on every machine in my cluster. Or actually, more concretely, I want to run it on some machines in my cluster, but not other machines in my cluster, and I don't want to double it up. We had all sorts of silly hacks and ways to work around this. What we instead came up with is a new concept called a daemon set. A daemon set is similar to a replication controller. It has one job, except it selects based on the node availability, and it makes sure that you have one copy running on all of the nodes that match the selector that you've given it. Selector is a concept that keeps coming up, so I just need to emphasize it. It's the only way in Kubernetes of doing grouping. So you lump all your things together by giving them common selectors, think like SQL select where, and now you can select what nodes you want to run on, because a node is also represented in our API. The benefit here is it uses familiar tools, familiar patterns that are consistent, common API across everything. This is beta in Kubernetes 1.2. Beta in our language means you can rely on it to be forwards compatible, and we will not break you. Or at least we will give you a path forwards to whatever the final solution is. So let's do it again. So the first thing I did is it cleared out all the labels. So you can see here I've done a select on my nodes, and on all the nodes I've gotten a listing of all of the labels that are on the nodes. Unfortunately, the formatting is sort of Go-ish, but if you look at it, you'll see that in there are no colors. I'm going to use color as our selector. So the first thing, again, I'm going to do is I'm going to create a service so that I can actually poke at these things and you can see what's happening. So I've created the service. So here is my daemon set. It's a little bit simpler than a deployment. I'm just going to run one container that is called hostname, and all it does is serve its own hostname, right? And this way you can see how many replicas you're running. You can prove that you have multiple of them. So go ahead and create. And just to show you what it looks like right now, my API server is telling me that I have asked for 0 nodes and I have 0 nodes scheduled. Sorry, the part I missed out. I'm only selecting nodes that are color red. So currently there are no red nodes. So now in the bottom, I'm going to do the same thing. I'm going to go hit this service. But it's going to time out because there's nothing backing the service at the moment. So in the top, I'm going to one by one color each node. So I apply a label to the node, and there you see it now coming up on that one node. You can see now I've got 1 of 1. I color the second node and describe it, and I now have 2 of 2, although it's not hitting it through the service yet. Oh, 1 running. Oh, 1 failed. Why did 1 fail? Well, that's interesting. Live demos. So we'll run it again. And now I say I have 2 running. I'm not sure why the 1 failed. I'm going to do live debug on stage. No, I'm not Kelsey good. You can see here now that you can use this to control your nodes. For example, you can use this to run a logging agent or a monitoring agent or something that you need to present on each node, maybe a fuse daemon that mounts some common storage thing that you need access to. Whatever your use case is, you can now do this on those nodes in your cluster that are responsible for this sort of thing. It's a really simple subsystem. One of the core tenets of Kubernetes is that we have concepts that do one thing. So rather than build out this as a bunch of features on top of replication, we decided we would build a whole separate API object for it. All right. The next big thing that we're bringing in 1.2 is horizontal pod autoscalers. Whew, say that 5 times. What an HPA is a way of taking a set of pods and automatically growing them. So we've built a concept that hooks into your replication controller and looks at your stats, currently looks at CPU usage. We have custom metrics coming soon. And based on those stats, it will scale or unscale your replication controller. So now, if you have, say, CPU usage and there's a giant scandal and politicians are being arrested and you need to grow your application, it can automatically grow as you're filling up your CPU. It operates within user-defined bounds, so you're not going to have an unlimited bill at the end. But you can set, say, I want no less than 3, no more than 100 copies. What it does is now is it gives you efficiency, right? It'll drive you down to the minimum number that you need to satisfy the constraint of your metrics. The power here now, imagine you can introduce your own custom metrics, QPS or users served or hamburgers eaten, whatever is important metric to your application, you can link it up to this and it will grow or shrink your application as you need. This is also GA in Kubernetes 1.2. We have another concept called jobs. So we talk a lot about containers, and when people think about containers, they think about these long-running services. It was on Alex's slide earlier that the vast majority of containers are long-running services, right? But at Google, we have some experience here. I cut my slide, but the number we like to throw out is 2 billion. We start 2 billion containers every week. And the vast majority of those 2 billion containers are not servers that run forever, right? They are MapReduce jobs that run for 25 seconds and process some chunk of data and then they exit. So it's important that an orchestration system be able to handle this. So we've introduced this concept of a job, which is a run to completion concept as opposed to a run forever. It will restart containers if they fail, but as soon as they terminate, it considers them done. If they terminate successfully, it will gather the statistics on it and then it will continue to run the job. This is really built, designed for big data batch sort of work. It's very similar to how we run things inside Google. So, shooting for 3 demos in 25 minutes. So here's my job object. Because we love some YAML, I'm going to match the demo jobs. I set parallelism 5, which means I can run 5 at a time, but I need 15 to complete, okay? And then for fun, the command at the bottom there is it's going to sleep for 5 seconds, and then it's going to pick a random number, and 1 out of 4 times it's going to fail, just so that you can see that we're actually handling failures. So we go ahead and create that and show you the description, and it's already started running, right? You can see 5 running, 0 succeeded, 0 failed. So I'm just going to keep hitting this, and it's going to show you these are currently what's running in my cluster. Whoops. And you can see now that I've had 5 succeed, 1 fail. We'll just sort of run this in a loop. You can see 10 have succeeded and 5 have failed. We must be at the end because there's only 3 running. And you can see 14 succeeded, 6 failed. The last one, the last man standing. It's always the straggler, isn't it? 15 have succeeded. So we'll do a final summary, and you can see here all the pods that have run under this job, and you can see that about a quarter of them failed through the course of this process, but we've now gathered all of the status codes out of all these containers. Now you can see how you could turn this into a MapReduce or a big data processing pipeline. So in the last few minutes that I've got, I want to go over a couple more features. So secrets, I think it was Alex, somebody mentioned secrets earlier, about the separation of secrets from applications, right? The goal here, you have an application, it needs to have access to something, right? There are very few applications that are coming out now that don't need access to something. That might be an SSH key, it might be a password to the database, it might be some role-specific information, it might be an API access token. There's a million things that we can consider secrets. You don't want to build your secrets into your container images, duh, right? Because then when the secret changes, you have to rebuild and retest your container image. And one of these fundamental concepts of containers is you only retest and rebuild when you need to. So 12-factor, everybody's read 12-factor, yeah? 12-factor says your configuration comes from the environment. Secrets are part of your configuration. Your environment, in this case, is Kubernetes. But we don't want people to write their applications that are coupled to Kubernetes, right? This is not a lock-in play. The goal here is not to have you not be able to move off of Kubernetes. The goal here is to let you write your application the way you want to write your application. So we've abstracted the secrets method, so you don't have to actually talk to our API at all. You just feed it in through your YAML, and we will inject it into your container as either a virtual file system, like it's a tempfs that we mount some files into, and we'll manage those files and put the passwords in those files for you. Or you can inject it as an environment variable, which is new in 1.2, an environment variable of your naming. So you don't have to read our environment variables. You can put it into whatever envar you used to use. I have a demo of this, but I cut it for time. I'm happy to do more demos. I could do this all day. I have literally a dozen or more demos that I'm not going to do on stage that I can be happy to do for people afterwards. Similar to secrets, we have a concept called a config map. So secrets are secret, and they imply some sort of access control. Config map is a slightly different concept, but very similar in form. You have some configuration that you want to inject into your application. Again, you don't want to build your config into your container image because your config is much more likely to change than your application is. So we have a new object in our API called config map. Config map lets you store arbitrary string-to-string values in our API, and through the same technique, we can inject them through the file system. If you go into your API and you change your config map, we will dynamically update the files on disk underneath your application, so your application can actually just notify on those files and wake up whenever something has changed. This allows you now to inject aggregated configuration or whatever you're using into your application. No more flags, right? No more configuring your Docker run to have a bunch of flags. You can put all your flags into this config map and use it live. Also supports environment variables. Obviously, I can't update envars real time. Sorry. So also new since a year ago, HTTP load balancing. We heard this one loud and clear from people. L3 load balancing is cute, but what about HTTP and HTTPS? So we have a new object called Ingress, which is our L7 load balancer. It is an API purely, so the Kubernetes, I wear two hats. Kubernetes has an API called Ingress. You describe what you want out of an HTTP server, and then depending on where your cluster is running, you have backends that satisfy that API. So in Amazon, you run the Amazon load balancer driver. In GCE, you run the GCE load balancer driver. If you're running on-prem, you can run HA proxy, you can run Nginx. The community is developing a whole bunch of really interesting plugins here. So this allows you to have your HTTP applications using your host headers, using your URL paths, breaking it up into multiple backend services. So this is a layer that builds up. Now with SSL in 1.2. So I mentioned real briefly earlier persistent volumes, and this came up earlier too about your databases. So we have this concept called a persistent volume, which lets you abstract storage away from your application. Think of it as an indirection, a pointer. When you run your job, you say, I want the storage that is named foo, but you don't actually know what foo means. It might be an Amazon EBS. It might be a GCE persistent disk. It might be an NFS share. It might be Ceph. It might be Gluster. We support about 15 different volume plugins that you can use to back persistent volumes. So it's a higher level of abstraction. Again, decoupling you, the app developer, whoops, my alarm. Decoupling you, the app developer, from the underlying details of storage. Last one I'll do. Coming up in 1.3, we expect to have an alpha or beta release of our network isolation protocol. So you can define, essentially draw the graph of your application, who talks to who and who doesn't talk to whom, and enforce that at the network level. This one's pretty exciting to me. Scalability, we've just released 1.2. So we've met our SLO at 1,000 nodes and 30,000 pods in a cluster. This SLO is how we define what we think our scalability numbers are. That doesn't mean you can't run more. This just means where we've measured it. We've done a bunch of performance improvements. We've made things faster and more svelte, and we're planning to do more in the 1.3 cycle. Let people take their photos. I will publish all these slides later. Then the catch-all. This is a bunch of other stuff that's either new or coming soon that I just couldn't jam into 25 minutes. Sorry, I hope I got you. The last, I always end with this. Kubernetes is open. It's 100% open source, open design. We don't do anything in the back channel. We want people to participate. We try to have our conversations as open and public as we possibly can because it's all of you. It's the people who are using it who are helping us define what this thing is actually going to be. So if you have an idea, if you have a problem, if it doesn't work for you, please come talk to us. Send us an email. Come talk to me. I'll be around all day. There's several other Kubernetes people here. Come and talk to us, and we'd love to hear about what your needs are, what your problems are. Thank you.